All right, we're going to hit some problems that we may or may not have done in class, but problems that you should be responsible for. These are going to fall into the portion of do now that are right here. You're going to use linear equations to solve real life problems. See if I can get it going here a little bit. Okay, the one thing about this book that you got to pay attention to is the questions use information from the words and also from the diagram. So I know these problems are easy generally. I think the real challenge here is to be able to write an equation. I know you can probably solve it without an equation. I want to see if you can solve it with an equation. All right. A discounted amusement park ticket costs $12.95 less than the original price. Write and solve an equation to find the original price. So here's a discounted price we're going to need. Original price is P and $12.95 less than. I think if you think about it, we take the original price and we want to go $12.95 less, which implies subtraction, and that's going to equal our discounted price. And we have our equation. From there, we'll solve by doing an inverse operation of subtraction. And we'll get P equal to 56.95. And we most definitely should label because it's a money problem. All right, you and a friend are playing a board game. Your final score is 12 points less than your friend's final score. Write and solve an equation to find your final score. Let's do something like this. Here's my friend's final score. All right. My final score is 12 points less than. So I know mine is smaller than my friend's 195. So I'm going to have to add 12 to get to 195. If we go to do the inverse operation to solve, one thing that's interesting to me in these two sets of problems is we use a less than here and use a plus sign. We say less than here, we use a minus sign. So you have to be careful in how you're thinking out your problems and what you're using. The words don't always give you the same sign depending on how you think out the problem. All right. This one pulls on information that a quadrilateral has an interior of 360-degree sum. So if we're looking at number 17 here, all four of these angles, 1, 2, 3, 4, need to add up to be 360. So if we go x plus 100 plus 120 plus 100, instead of equal to 360, we're going to have a chance. We will be combining like terms here and go x plus 320. Like terms have the same variable, same degree, so same exponent. Constants have no variable and a degree of 1. So those are all constants are like terms. From there, we go the opposite or the inverse of plus. And we have x equal to 40. Now if we go on to number 18, again, still a quadrilateral. So this plus this plus this plus this equals 360. X plus 150 plus 77 plus 48 equals 360. Combine our like terms of this, this, and this. So use my handy dandy calculator here in a little bit. Get x plus 275 equals 360. We do an inverse operation, minus that, minus that. And get something like x equals, ooh, that's a weird 8, 85. All right, and number 19, still quadrato, so this plus this plus this plus this. So 76 plus 92 plus 122 plus x equals 360. So if we go this, and this, 76 plus 92 plus 122, we get 290. 290 plus x equals 360 minus 290 minus 290, and we have x equal to 70. All right, final problem here. Number 20, we got this plus this plus this plus this. So if we go 115 plus 60 plus x plus 85 equals 360, we can combine our like terms, our constants of these. So 115 plus 60 plus 85 is 260. X plus 260 equals 360. We do the inverse of addition, so we subtract 260 from both sides. We get x equals 100. Good application problem of simple equation solving, reminding you of prior knowledge that quadrilaterals, which have 4 sides, have an interior sum of 360 degrees. Okay, again, I want the challenge to be here in this problem that we are trying to write an equation, right? So usually the question contains our variable. How many degrees did the temperature fall? So if we start at one temperature, when we say fall, it's implying subtraction. So we're going to fall x degrees to get to -5. All right. If we do the inverse of a positive 20, we got to subtract 20. This negative stays with the x, so it's still -x equals -25. You got to remember that -x implies -1 times x equals -25. So then we're going to divide both sides by -1 and get x equals a positive 25. Read number 43. The length of an American flag is 1.9 times its width. What is the width? So I'm going to make a variable of w equals width. So 1.9 times the width equals 9.5. Remember that we don't need a multiplication sign when we just put a number next to a variable. From there, we got to divide by 1.9, divide by 1.9. We get 9.5 divided by 1.9. We get w equals 5. Powering on. The balance of an investment account is $308 more than the balance 4 years ago. The current balance is $4,708. What was the balance 4 years ago? So this is going to be my variable. You see what I'm doing here? This is called defining the variable so people know what it stands for. So 308 more than 4 years ago equals this. If we go subtract this, subtract this, I think we get something like x equals 4,400. We should label this with money. Going back, didn't think about we should label this with feet. We should label this with degrees. In real context problems, we should be labeling. Again, the challenge in these 3 problems is I think you can reason your way there if you have to, but the challenge is trying to be able to write the equations. All right. Last 2 problems of the video. This one up here is one of my more favorite ones. Tatami mats are used as a floor covering in Japan. One possible layout uses 4 identical rectangle mats and 1 square mat, as shown. The area of the square mat is half the area. The square mat is half the area of the rectangular mat. The total area is 81 feet. Write and solve an equation to do 1 rectangular mat. So I'm going to use R equals 1 rectangle mat. It's interesting because now you got to use nothing but the diagram to set up an equation. And what I see is I see one rectangular mat, two rectangular mats, three rectangular mats, four rectangular mats. And I see a little half one in here because a square mat is half. So what I'm going to write is 4.5 R equals 81 feet. So from there, divide by 4.5, divide by 4.5, 81 divided by 4.5, and we get R equals 18 square feet. The length of a rectangular mat is twice the width. Use guess and check to revise. So the length is twice the width. So if this is the width and here's 2W, here's something I see. It says guess and check, which is cool. I'm going to give you a little bit more advanced version of this. So length times width equals our area of 18 that we just solved for. W times 2W. You don't necessarily know this yet, but it would be this. From there, we would divide by 2, and we'd have W squared equals 9. From there, we would square root and get W equals 3. So the dimensions, the width would be 3, the length would be 6 because it's 2 times the width. Okay, you got to be careful on number 47, how you read it, and understand if there's distracting, because there is some distracting information there. You spend $30.40 on 4 CDs. Each CD costs the same amount and is on sale for 80% of the original price. Write and solve an equation to find how much you spend on each CD. Cost of CD, right? The thing you also got to know is this is a discounted, because we're going to go just 4x equals 30.40. So if we go 30.40 divided by 4, divide by 4, divide by 4, get x equals $7.60, right, is what we spent on each one. This 80% doesn't all the way bother us, right? And B, it says next day the CDs are no longer on sale. You will have $25. Will you be able to buy 3 more CDs? Well, let's look at something like this, right? Let's have a new variable. Let's call it Y and say the original price of a CD. Now we're going to use this 80%, because if we take 80% of the original price Y, that should end up at $7.60. From there, if we divide by 0.80 and divide by 0.80, 7.60 divide by 0.80, our Y will equal 9.5 or $9.50. So then if we take $9.50 and times it by 3, because we want to buy 3 CDs, we would need $28.50. So this math I'm going to count as my reasoning, and our resounding answer is no, $25 will not be enough. Just to backtrack a little bit, understand that 0.80 is the way that we use 80% in a math problem or in an equation like this. All right, that should get you through these problems, and I look forward to seeing you in the next video.